Hi everyone, I welcome you all to the video solutions of NTSE Stage 2 2019. Today for our discussion we will be taking up the code 1315 and I will be helping you out with the solution of the physics part of a SAT paper. So let's have a look on to the first question of today's paper, which was question number 61. Question number 61 and 62 were direction based questions, so let's read the directions for more clarification. So this says, suppose that the acceleration versus time graph of a particle that starts from rest at t is equal to 0 is as shown in the figure. So we are given this AT graph and the hidden hint in the direction is that it starts from the rest at t is equal to 0. So at t is equal to 0 the particle was at rest, so u was 0. Now we know, let's have a look on to the question number 61, which says at what instant does the particle come to rest for the first time. So here if you have a look on to this AT graph again, from this AT graph we can also draw the VT graph, and we know that the area under the AT graph gives us the change in velocity. So here I can write down the solution for this question. Area under the AT graph gives the change in the velocity. And we are assuming here, let at instant t the velocity becomes 0. So here if I just ask you to find out the area of this part of the AT graph, that will be the area under the curve, which will be the area of this rectangle, that will be 5 into 10, so this is 50. Okay. Now here we are assuming that in between 10 to 20 we know the particle was moving with the negative acceleration. So in this time interval, that is in the time interval 10 to 20 seconds, the particle will come to rest. Let us suppose the time instant is t. Now here I can write, that is 50 minus 10 in the bracket t minus 10. T is the instant at which the particle will come to rest for the very first time. Now this should be equal to 0. Why I am writing it 0 here? Because initially the particle was at rest and now at time t the particle is again at rest. So what is the difference? That is 0. On solving this I will be getting 10 in the bracket t minus 10 is equal to minus 50. This get cancelled out. Further, on solving this I will be getting t minus 10 is equal to 5, and this gives me t as 15 seconds. Okay. So at t is equal to 15 seconds, for the very first time the particle will come to at rest. So here if we have a look on to the options, you can see here that option number 3 is the correct option. So the answer of question number 61 is option 3. I hope this is clear to you. Now let's have a look on to the question number 62. So here I have the question number 62, that is based on the same acceleration time graph that we have discussed in the previous question number 61. Now here this question says that what is the total distance travelled by the particle during the given 30 seconds. Now this question becomes very easy if you just draw the VT graph. So to solve this question, what I am quickly going to do is I will be drawing the VT graph for the given AT graph. So here you can have a look on to this VT graph. I will be explaining you quickly that how I have drawn this graph. So here we are given in the AT graph that the particle was moving with the positive acceleration of 5 for the first 10 seconds. So when you will be calculating the area under the curve in AT graph, that will come out to be 50. Now as the particle was initially at rest at time t is equal to 0, so it means at the end of 10 seconds what is going to be the velocity of the particle? That will be 50 meter per second. Okay. Now for the 10 to 20 seconds, the particle was moving with the negative acceleration of minus 10, and you can have a look onto this AT graph again. Okay, so in between 10 to 20 seconds, the particle is moving with the negative acceleration of 10 meter per second square. So if you just calculate the area under the AT graph for that particular time interval, the particle's velocity at the end of 20 seconds will come out to be minus 50 meter per second. And after that, in between the interval 20 to 30, you can see the particle again attained the positive acceleration. Okay, so if the particle is moving with negative velocity and positive acceleration will start acting on the particle, it means still the velocity and acceleration are in the opposite direction, and hence the particle will again come to rest. So here you will see that at the end of 30 seconds, when you will calculate, the particle velocity will come out to be 0. So here this is how we are getting this AT graph. So here this time instant is 15 seconds that I have calculated in the previous question, that is question number 61. Okay, so here for the very first time the particle's velocity becomes 0 at t is equal to 15 seconds. You can simply calculate the area of these two triangles. You need to add them up to calculate the total distance. Okay, so if I just say the area of this triangle is A1 and the area of this triangle is A2, so I can write down the total distance is simply going to be the sum of A1 and A2. The area of this triangle is going to be half into base into height. What is the base? That is 15. What is height? That is 50 plus, again the base is 30 minus 15, that is 15. The height is going to be 50. Now in the calculation of the distance, we are not going to consider this area as negative. In the case of displacement, this area will be considered as negative, and then the answer will come out to be 0 as both the areas are equal. So here in this case you will be adding them up to find out the total distance. Now let's add them quickly. Now when you will solve this, this will come out to be equal to 750 meter. Okay, so let's have a quickly look onto the options which are available. So you can see here that option 3 is the correct option. So the answer for this question is option 3. So I hope these both questions 61 and 62 are very clear to you. Now let's move on to the discussion for the next question, that is question number 63.